and we're talking about perimeters and areas of similar figures. So we've been talking a lot about scale factor, which is the number of times larger or smaller one figure is from a figure that's similar to it. So like if you multiplied all of your sides by 2, if you doubled all your sides, your scale factor would be 2. The scale factor is the same thing as the similarity ratio. So a ratio is really just a way of comparing two numbers. We usually write it like this with a colon in the middle, but a ratio is exactly the same thing as a fraction. A fraction is just a comparison of two numbers as well. So we want to think of these terms as being interchangeable. We're going to use similarity ratio a lot when we talk about the area and perimeter of similar figures. So perimeter, of course, is the distance around the outside of a figure, or it's the sum of all of the exterior sides of a figure. So if we compare the scale factor to of these two triangles, we get 8 over 4, 6 over 3, and 10 over 5, which reduces to 2 over 1, which again we can write as a ratio instead of as a fraction as well. So this triangle is twice as big as this triangle. If we compare their perimeters by adding up the sides, we get a perimeter of 24 over here and 12 here. So the perimeter is also at the same scale factor or similarity ratio as the sides, which makes sense because side lengths are what make up perimeter. So the ratio of perimeters of similar figures is also the same ratio as the scale factor. Okay, so that's very important. Area, on the other hand, is just a little bit different. Area is a two-dimensional measurement. It's the measurement of how many squares or boxes it would take to fill in a figure, whereas perimeter is distance, which is one dimension. Area is two dimensions. So the area of our two triangles, if we use our 1/2 base times height, we have 1/2 6 times 8 or 24 and 1/2 3 times 4 or 6, we can see that the area is not at the same ratio as our perimeters. The area ratio is at 4 to 1. So if we compare that to the area of our if we compare that to the ratio of our perimeters, we can see that it's the perimeter ratio squared. So 4 is 2 squared and 1 is 1 squared. So therefore, the ratio of areas of similar figures is a squared to b squared. So again, the ratio of perimeters is the same thing as the scale factor or the similarity ratio, which is a to b. The area of similar figures is then a ratio of a squared to b squared. Again, keeping in mind that area is a two-dimensional measurement, which is why we square our ratio. And that's it. We're going to be applying that to finding areas and perimeters of similar figures, and I'll see you guys in class tomorrow.